Tell us your name and tell us your project.
My name is Dr. Robert Woodrow Wilson. The project that I worked on involved what was called a radio telescope. So a radio telescope is simply a device that is used to detect radio emissions from the sky, from things like stars, artificial satellites, and so on. During this project, we discovered a new type of radiation that's known as cosmic microwave background radiation, or CMR for short, which was found to pervade the whole universe. The discovery of CMR helped us better understand the origins and structure of our universe.
What were you guys trying to do or find?
The original goal of the project was to utilize MASERS, which is an acronym that stands for Microwave Amplification by Stimulated Emission of Radiation, in order to measure and amplify the radio signals that were traveling between the Earth and other galaxies. This was the main focus of the research of my colleague, Dr. Panzias, whom I will get into detail on later. My goal was to further research and map out radio signals from our Milky Way galaxy that are constantly traveling through the galaxy.
Where did the project or experiment occur?
We performed the experiment at Bell Labs in Homedale, New Jersey in 1964. We had used the antenna of the now obsolete ECHO satellite system to perform our experimentation and observations. Dr. Panzias and I had been working at Bell Labs for some time, with Panzias starting in 1958 and myself in 1962, until where we were able to both use the ECHO antenna for our research. Our time finally came when the Telstar satellite was developed, which had built-in transponders, which made the ECHO system of using the antenna and satellite transmission signals to large metal balloons in the atmosphere obsolete, leaving it open to us to conduct research with.
What other significant events were happening around the world at this time?
There were plenty of notable historical events that were happening in 1964, the year of our experiment. In the U.S., Lyndon B. Johnson won the presidential election in November of that year, beating out Democrat Barry Goldwater. This was LBJ's first term being elected into the presidency, but he was president in the prior presidential term after he was vice president, and then sworn into the presidency after JFK was assassinated in 1963. 1964 was also very successful for the progression of civil rights movement in the U.S., starting with the passage of the 24th Amendment in January, which abolished poll taxes for federal elections, which were originally meant to hinder poor African-American citizens from voting. Then, later in July, the Civil Rights Act of 1964 was enacted, which outlawed discrimination based on race, religion, color, sex, or national origin. In October, Dr. Martin Luther King Jr. received the Nobel Peace Prize for his civil rights efforts in the United States. He delivered his famous I Have a Dream speech in August of 1963, which really helped get the ball moving for civil rights. Also in August, the U.S. Congress passed the Gulf of Tonkin Resolution, which gave LBJ the Vietnam War. In popular culture, Cassius Clay, better known as Muhammad Ali, knocked out Sonny Liston in February, making him the new world heavyweight champion. It was also in 1964 that the Beatles released their first U.S. album, and in a very short amount of time, they had 5 of their songs in the Billboard Top 40 at the same time.
Who else was involved in the project?
As I mentioned earlier, my colleague at Bell Labs, Dr. Arno Panzias, was a key scientist involved in the project. Panzias was originally born in Munich, Germany, and came to the United States as a child refugee escaping Nazi Germany. He remained in the U.S. and studied here, and eventually earned his Ph.D. in physics from Columbia University. Like myself, he was highly interested in the use of MASERS. Another notable person was Dr. Robert Dick from Princeton University, who was known for being a firm believer in the Big Bang Theory, a theory I was originally opposed to until my observations in this experiment.
What was your role in the project?
My role in the project, as well as Dr. Panzias' role, was to maintain, operate, and record data and observations using the ECHO antenna satellite. While operating the antenna, we noticed a constant background noise or static in the radio waves the antenna were receiving. At first, we thought it was a problem with our equipment or possibly the large pigeon's nest that was in the satellite along with its droppings, which were both removed. The trap I used to capture the pigeon is currently at the Smithsonian. After cleaning the satellite, the static was still there at the same exact intensity. Next, we thought it could be sound and energy interference from nearby New York City, so we aimed the satellite towards the city, but yet there was no change in intensity of the static. Furthermore, we ruled out any possible seasonal effects because we had operated ECHO throughout all 4 seasons, and yet there still had been no change in the intensity of the static. We then sought out theoretical explanations, which is where Robert Dick of Princeton comes into the picture. Dick heavily studied the Big Bang Theory and inquired that if there is, in fact, had been a big bang in which the universe originated, then there must be residue of the explosion which after billions of years should now take the form of low-level background radiation. Our findings of the persistent static in our ECHO satellite was evidence of this radiation, which became known as cosmic background radiation, CMR for short, as I mentioned earlier.
What impact did your project have on the physics community?
The findings of our experiment brought crucial evidence to help support the Big Bang Theory and help solidify it as a standard model for the structure of the universe. The previously held theory, a theory I used to believe, of the universe was the steady-state model, in which it is believed that there was/is no start or end to the universe. Our findings, along with Edward Hubble's discovery of redshift and the constant expansion of the universe, helped solidify the Big Bang Theory. Furthermore, it brought cosmology and astrology into light as a respectful, meaningful science. Prior, it was seen as a waste of time and foolish. Dr. Panzias and I received the Nobel Peace Prize for our experiment in 1978.
What was your path to Bell Labs? Where did you grow up and go to college?
It all started back in my home state, Texas, where I was born and raised. I was born in Houston, Texas on January 10th, 1936, and went to Lamar High School in Houston. I then went on to study physics at Rice University for an undergraduate. After that, I went on to California, where I attended the California Institute of Technology and earned my PhD in physics. After other jobs and research, I was eventually hired at Bell Labs in New Jersey, where I would soon be involved in work that not only changed my life, but changed our understanding of the universe.